We're going to start our discussion about counting principles with the fundamental counting principle that kind of kicks everything off. It says if you have a decision M, and you have M choices for that, and you have a decision N, which has N choices, then the two decisions can be made M times N ways. You multiply your number of choices together. All right, that can answer a variety of problems. Some are pretty simple, like this first ice cream shop one. If you can have 3 cone sizes and 15 flavors and 8 toppings, how many cones are possible if you can choose 1 flavor and 1 topping? So remember, you're going to have to pick your cone and your flavor and your topping. So you're going to make 3 decisions. Okay? Your cone, you have 3 choices for. And for your flavor decision, you're going to have 15 choices. And for your topping decision, you're going to have 8 choices. And so if you multiply those together, you'll get your answer. 360 different cones. All right. Some of them make you have a little prior knowledge, like number 2 here. If a Virginia license plate consists of 3 letters followed by 4 digits, how many different license plates are possible? So this time we're going to have to make 3 letter decisions and 4 digit decisions. So we're going to make 7 decisions. So we're going to need 7 numbers multiplied together. Okay? And then we have to think about letters. How many letters are there? Well, remember, I'll put this off to the side because this is going to be a fact that's going to come back. There's 26 letters. And for digits, digits means the numbers 0 through 9, which if you count the 0, that actually means you have 10 choices. So whenever a math problem says digits, think 10 choices, not 9. Okay, so what does that mean? That means 3 letter choices. We're going to have 3 26s. 26 choices for each of the letters' positions. And then 10 choices for each of the digit decisions. And so we're going to have 26 times 26 times 26 times 10 times 10 times 10 times 10. If you want to use a power, you can. That would be 26 times itself 3 times, so 26 to the 3rd, times 10 times itself 4 times, so 10 to the 4th. Let's see, I gotta think about where my commas would go here. That's 1 7 5 7 6 and then 4 zeros. So 175,760,000 different license plates in that configuration. All right, Nick's science test has a section with 12 true-false questions. How many different ways can Nick answer these questions? Okay. Now this one, we're going to make 12 decisions. He's going to have to answer 12 true-falses, so he's going to make 12 different decisions. I'm not going to write down 12 little spots. That's what we would do if we have more space. How many choices does Nick have for each one of those? True or false. So he's got 2 choices. If it had been multiple choice, we would have had to know how many letter choices there were. But here, true, false, that's 2 choices. So he has 12 different questions. So he's going to have to make 2 choices 12 times. It would be 2 choices for question 1, 2 choices for question 2, 2 choices for question 3. So there would be 12 twos for us to write down together. The short way would be 2 to the 12th power. 2 times itself 12 times, 4,096. Okay, and the last one. To enter the Clayton home, they have to enter a 4-digit code. How many codes are possible? Hey, there's our friend Digit again. Digit means 0 through 9, and they have to do 4 of them. So they're going to have to make 4 choices when they enter their passcode. When they set their passcode, they're going to have 10 choices for each one of those. 10 to the 4th for the shortcut. So that's a 1 with 4 zeros behind it. So 10,000 different codes. Okay, so that ends the video for the fundamental counting principle. If you have questions, ask in class.